Welcome all. Today we are going to take a class on combination of two mutually two mutually two mutually perpendicular simple harmonic vibrations. Okay, so let us take here first condition is equal frequencies. If the two vibrations are having equal frequencies. Okay, so for this, what I am going to do here, I am going to take two simple harmonic vibrations having the same frequency, x equal to a sine omega t plus pi. Okay, and again y equal to b sine omega t. So what is A? Amplitude. What is B? Amplitude along the vibration, where A is amplitude along the x direction. Okay, so what is pi there? Where the pi is the phase difference between these two vibrations. Okay, phase difference. Right? Now, see here what I am doing here. Sine omega t. Let us assume this is what equation 1 and this is equation 2. Here I am assuming from equation 1 sine omega t plus pi equal to can be written as where so from equation 2, let us take from equation 2 sine omega t only. Let us take sine omega t only here. Sine omega t equal to so y by b, right? Y by b. Now we know that one formula sine square theta plus cos square theta equal to 1, right? Sine square theta plus cos square theta equal to 1, right? All right. Now from this equation we know that cos theta equal to under root 1 minus sine square theta. So using this equation where we'll get cos omega t equal to under root 1 minus sine square omega t, right? So what is sine omega t here? Sine omega t can be written as cos omega t, and where sine omega t substitute under root 1 minus sine omega t. In place of sine omega t we have to substitute y by b, y square by b square. So this is what cos omega t and this is what sine omega t. Let us assume this is equation number 3 and this is what equation number 4. Okay, now so let us expand from equation 1 from equation 1. So how can we write from equation 1 x by a equal to sine omega t plus pi. Okay, so now we have to expand this one. We know that sine a plus b can be written as sine a cos b plus cos a sine b. All right, so using this function let us expand this equation. Okay, then what we get here if we expand that one. Okay, now we'll get sine x by a equal to sine omega t plus pi, that equal to sine omega t plus pi equal to we'll get sine omega t cos pi plus cos omega t sin pi. Okay, right. So from this equation again x by a equal to, so we know that what is sine omega t? Sine omega t is nothing but y by b. Substitute here y by b. Okay, and cos pi remains same, no change, and plus what is cos omega t? Under root 1 minus y square by b square and the sine pi. Okay, so now from this equation we'll write x by a minus y by b into cos pi, so that equal to under root 1 minus y square by b square into sine pi. Okay, now squaring on both sides. See what we get squaring on both sides? We'll get there. So squaring on both sides, x by a minus y by b cos pi, okay, whole square equal to under root 1 minus y square by b square into sine pi whole square. Okay, see what we get finally? We'll get there, expand this function, we'll get there x square by a square plus y square by b square, okay, cos square pi minus 2xy by ab cos pi, so that equal to we'll get there 1 minus y square by b square into sine square pi, okay, into sine square pi. All right, so finally we'll get there here. Take this term to the left side, then we'll get x square by a square plus y square by b square cos square pi, okay, and then we'll get plus y square by b square sine square pi, so that equal to, and here we have minus 2xy by ab cos pi, okay, so that equal to sine square pi. Okay, so finally what we get here, finally we'll get there x square by a square plus you take common here y square by b square common, we'll get sine square theta plus cos square theta equal to 1. Then we have only y square by b square minus 2xy by ab cos pi, so that equal to sine square pi. Okay, so this is the resultant equation which represents oblique ellipse. This equation represents oblique ellipse. This equation represents oblique ellipse. Okay, so this is the resultant equation. Let us assume this is what equation number 5. Equation number 5. Okay, next. So let us see few cases here when pi equal to 0. Now the first case, now we got equation number 5. What is that? Equation number 5 represents, equation number 5 is what? X square by a square plus y square by b square, okay, minus 2xy by ab and cos pi, so that equal to sine square pi, okay, sine square pi. Now let here, where the case is case 1 is when pi equal to 0. When pi equals 0, that means there is no phase difference between the two vibrations. Then what happens? If you take pi equals 0 in this equation, then pi equal to 0, sine pi equal to 0 and cos pi equal to 1, then x square by a square plus y square by b square minus 2xy by ab, okay, equal to 0. With this equation, what we get there? X by a minus y by b whole square equal to 0. Okay, so from this equation we'll get here x by a, okay, and x by a minus y by b equal to 0. Finally we'll get there here x by a minus y by b equal to 0, and finally we'll get y is equal to b by a into x. Here we'll get plus or minus okay, and finally plus or minus, here we'll get plus or minus. So y equal to b by a into x. What this equation represents, we know that the equation of line can be y equal to ax plus c. This one represents equation of line, right? Y equal to ax plus c. So here we got y equal to plus or minus b by a into x, which is similar to this equation. All right, so this represents two coincident straight lines passing to the origin. See there, this represents here, this equation represents here the phase difference between two vibrations is 0. Then what happened here, this is the actual picture, and where it represents equation of line, then finally two coincident straight lines passing through the origin and inclined to x-axis at angle theta given. See there, like this we'll get, okay, here it is theta. All right, so two vibrations, so the resultant vibration is straight line that is passing through the origin O. Okay, so this is what amplitude A along the x direction, this is what B along the y direction. All right, here where pi equal to 0, phase difference is 0, phase difference is 0. Okay, so this is the case 1. Okay, case 1. Now let us see case 2. In case 2 we have to assume that here one more thing, then angle between them, if you take where the angle theta can be tan inverse b by a, tan inverse b by a. Now let us see case 2. Now let us see case 2 here. This is what case 1. Now case 2, here what I am assuming pi equal to pi by 4. If you take pi equal to pi by 4, what about sin pi? Sin pi equal to 1 by root 2, and also cos pi equal to 1 by root 2, right? 1 by root 2. All right. Now the resultant equation can be written as x square by a square plus y square by b square minus 2xy by ab. So 1 by root 2 equal to here also we'll get, here it is what, sine square pi, then we'll get 1 by 2 only, we'll get there 1 by 2. All right, now so this is which equation represents oblique ellipse. This equation represents oblique ellipse, oblique ellipse. Now the picture is like this. The resultant vibration can be like this. Resultant vibration can be like this. Okay, so this is what x, y, and where the phase difference pi equal to pi by 4. Okay, so this is what resultant oblique ellipse. Now let us see case 3. Case 3 here can be pi equal to pi by 2, where pi equal to pi by 2. If you take pi equal to pi by 2, what happened? Substitute in the equation pi equal to pi by 2, will get a sin pi equal to 1 and cos pi equal to 0. Then finally we'll get x square by a square plus y square by b square equal to 1 will get there, right? So what it represents, this equation clearly represents equation, the resultant path can be ellipse. The resultant path can be ellipse. Now axis coincide with the coordinate axis, and where the picture is like this. See there, now the picture is like this. This represents ellipse. Okay, ellipse. This is what oblique ellipse, this is what ellipse only. Okay, now the case 4, let us assume a equal to b. In case 4, if you take a equal to b, what happened, you know very well that when case 4 where a equal to b and where pi equal to pi by 2, in that case we'll get only x square plus y square equal to a square. So what it represents, this equation represents equation of circle, equation of circle. Now the resultant path of the vibrations can be circle. See, that can be like this. Sorry, we'll take circle shape just simply. Okay, so just like you take like this circle shape, right? So where this is what equation in which where a, and this is what where in the case a equal to b and where pi equal to, here pi equal to 90 degrees, that means pi by 2. Okay, so this is all about circle. Okay, circle x a square plus y, x square plus y square equal to a square. Now the case 5, where pi equal to 180 degrees, where pi equal to 180 degrees, see then what we get in this case. What we get in this case, if we take pi equal to 180 degrees, you know that sin pi equal to 0 and cos pi equal to -1, just like case 1, and we'll get a square, x square by a square plus y square by b square plus 2xy by ab equal to, will get 0, and finally x by a plus y by b equal to 0, right, plus square equal to 0, and here we'll get plus or minus x by a plus y by b equal to 0, and finally we'll get y equal to plus or minus b by a into x. This is also similar to y equal to x plus t. This is what it, which represents a line. Then the two vibrations coincide along the line which is passing to the origin O. So now the shape is like this. You know that, which this can be like this. See there. So this is exactly opposite to the case 1 where pi equal to 180 degrees, right? Pi equal to 180 degrees, that is nothing but pi. Okay, so this is where angle theta, and this represents amplitude A and this represents amplitude B. Okay, now the case 6 is when pi equal to 3 by 4. Already I have seen pi equal to pi by 4. Now if you take pi equal to 3 pi by 4, what happened? Let us see here. If you take pi equal to 3 pi by 4, this is what case 6. Pi equal to 3 by 4. If you substitute pi equal to 3 by 4, we'll get there sin pi equal to 1 by root 2 and cos pi equal to minus 1 by root 2. So using this equation, we'll get there x square by a square plus y square by b square, using this condition, minus 2xy by ab into minus 1 by root 2, that equal to 1 by 2. Alright, now see what happened, what it represents. This equation represents oblique ellipse. This equation represents oblique ellipse. That means the resultant vibration can be in the direction of oblique ellipse. Okay, so here we'll write using this one. Now the picture can be like this. See, they're exactly opposite to the pi by 4. This is what 3 pi by 4. Now the picture is like this. Okay, picture is like this, where pi equal to 3 pi by 4. All right, so this is x direction, y direction, right? So this is the shape. So now this is the topic where we are taking two vibrations, simple harmonic vibrations, where the case is where the frequencies are equal. Then the resultant vibration can be having these 6 different types of paths. Okay, so this is one of the question from this chapter.